Assalamualaikum and good afternoon to our lecturer Tengku Nazin bin Tengku Ibrahim. So my name is Muhammad Nabi Fan bin Muhammad Saludin, and my group members is Muhammad Khairi bin Kamaru Hatta, Muhammad Syafiq Umar Azhar, and Muhammad Sukri bin Baharudin. We are from group 6 and we are going to present our assignment for electronic digits. So let's go for the introduction. So, flip-flop. A bistable multivibrator, commonly known as a flip-flop or lush, is a circuit that has two stable states and can be used to store state information. You can change the state of the circuit by applying signals to one or more control inputs and one or two outputs. This is a basic component of sequential logic storage. Flip-flops and latches are among the basic components of digital electronic systems used in computers, communication system, and many other types of system. So, flip-flops and latches are used as components of data storage. One of the flip to flop states is 1 and the other is 0. A device that stores one bit of data, such circuits called sequential logic in electronic devices, can be used to store state data. So the output of a finite state machine and subsequent states depend not only on the input but also on the current state and thus the previous input. It can also be used to synchronize the variable timing input signal to the reference timing signal and count the pulses. The flip-flop can be edge-triggered or level-triggered, asynchronous, opaque or transparent, synchronous or clock. Previously, level-triggered and edge-triggered circuits that use gates to store 1-bit data were collectively referred to as flip-flops. Flip-flops are currently only used to describe time-control circuits. The simple ones are sometimes called transparent latches. So in this language, level-sensitive flip-flops are called transparent latches, and edge-triggered flip-flops are called flip-flops. In both terms, a latch is a device that uses a single trigger to store any number of data bits, and a flip-flop is a device that stores only one bit of a data. To avoid confusion, you can use the terms edge trigger and level trigger. So we have 4 different type of flip-flop. So the first one is flip-flop SR. So SR bring the meaning set and rest. So the set rest SR flip-flop is the most basic type of bistable latch and bistable multivibrator because it serves as the foundation for all other forms of flip-flops. The fundamental SR flip-flop is a crucial bistable circuit. Two cross-coupled digital NAND gates like the TTL 74L S00 or two cross-coupled digital NOR gates like the TTL 74L S02 are used to build the SR flip-flop. Due to the fact that SR bistables and flip-flops alter or react right away to change in their inputs, these devices are typically referred to as transparent. Asynchronous sequential logic circuits such as SR flip-flops are said to be composed of digital logic gates and feedback. So the fundamental SR flip-flop has two inputs, S for set and R for reset, and two outputs Q, and one input is S. So the next type of flip-flop is JK flip-flop. So what is JK flip-flop? So the JK flip-flop is perhaps the most popular flip-flop design since it has many characteristics with the former SR flip-flop. The designation J and K were initially employed at the time the flip-flop was developed, even though they have no true meaning or connection to any particular description and are not a part of any other digital device. The J stands for set in the JK flip-flop and the K stands for reset. So the input sequence S equal to R is equal to 1. Combination is prohibited, as we previously observed, but the SR flip-flop has two or even 3 relevant input combinations, and it is simple to modify to provide other switching functions. and the JK flip-flop followed is sometimes seen as a ubiquitous gadget. All four potential input configurations, no change, set, reset and toggle are valid for the JK flip-flop since it has two inputs, which is J and K. It is switches states when one of its inputs is high, with the J input functioning like the S and the K input acting like the R and acting like the R. And the JK flip stunning flops feature is that it toggles or switches from 0 to 1 or from 1 to 0, generating its own complement state when both J and K are high at logic is 1, which is 1 is more higher than 0, as we know. So the next type of flip-flop is flip-flop in D. So what is flip-flop in D? So the D-type flip-flop, also known as a data latch, only has one input, which is the D or data input, along with a clock input CLK and the customary two outputs Q and Q. The D component of the flip-flop is sometimes known as a delay input because it delays the transfer of digital data by one clock pulse between its input and outputs. By simply attaching an inverter between the S and R input such that the input goes into the inverter and the output goes back into the S input, it is simple to create D-type flip-flops from an SR flip-flop. So D-type flip-flop is more simple than SR flip-flop to create the flip-flop. And the last type of flip-flop is T flip-flop. So what is the T flip-flop? So with the JK flip-flop design, we observed earlier that the output will switch on application of the subsequent clock cycle if J equals to K is equal to 1. Then all that is required to change flip-flops into toggle devices is to connect the inputs high. And the JK flip-flop, also known as the D-type flip-flop, can be converted into a T-type flip-flop by connecting the J input and the K input to logic level 1, albeit this is not a commercially available option because the flip-flop switches states each time it is activated as at its clock input while J and K are high. The output of this clock input, which toggles, become a 1 if it was previously a 0 and a 0 if it was previously a 0. So 0 is the I guess that 0 is the main output for this T flip-flop. So what is the so these are the application of flip-flop. Number 1, we go to frequency of divider, and second, counters, next storage register, shift register, data storage, bounce elimination switch, latch, data transfer, memory, and the last one, register. So we go to counter. So what is a counter? So a counter is a device that keeps track of and occasionally displays the frequency of a certain event or process, frequently in connection to a clock signal. So digital electronics employ counters for counting purposes. They may keep track of certain circuit occurrences. So and then we go to, so this, we have two different type of counter. So the first one is asynchronous counter. Asynchronous counters are frequently referred to as ripple counters because data seems to ripple from one flip output flops to another's input. Utilizing divided by n counter circuits, they are implementable. Any module's number count may be generated using truncated counters. So this is the example of 3-bit asynchronous counters, as you can see at my screen right now. So the next one is synchronous counter. What is synchronous counter? Synchronous counter, also called because the clock input of all the individual flip-flops within the counter are all clocked together at the same time by the same clock signal. So in synchronous counter we have clock pulse as the counter, okay, by the same clock signal. So these are the example of the synchronous counter, and it follows by clock pulses. Thank you. And next one is register. A register, a collection of flip-flops. So single bit digital data is stored using flip-flops. By combining many flip-flops, the storage capacity may be extended to accommodate a huge number of bits. We must utilize an n bit register with n flip-flops if we wish to store an n bit weight. So what is the function of the registers? So the function is to data storage, which is memory device, and data movement, which is shift capability in transferring data. So the movement of data in transferring, you know. So as you can see in the table is the example of application. This is if the counter is digital clock, so the example of application is in vending machine, so to hold data and address as register. So counter register is kinda relatable, okay, to in one system. And for frequency counter we have in video games. So and register is storing data in digital form. And for the next example of application is text parsing. For counter we use analog digital converter, and for register we use cache memory in CPU. I mean, like, register is being used for cache memory in CPU. And the last one is CPU controllers. So for counter, why for CPU controller? Because with some change to its design, the counter can be used as a frequency divider circuit. So why is a register is being used for CPU controllers? Because it used as a parallel to series converter, which converts parallel data into series data. So those are the example of application for counter and register. So finite state machine, FSM. So the which is FSM. So the phrase finite state machine, also known as finite state automation, is defined as follows. A calculating model known as FSM can be carried out using hardware or software. So this is employed in the development of a few computer programs and sequential logic. Problems in areas like mathematics, gaming, linguistics, and artificial intelligence are solved with FSMs. So there are two types of state machine or finite state machine, which is the number one is Mealy state machine. Next state output depends on the present internal state only, and the second one is Moore state machine. Next state output depends on the present internal state, but not only that, also with input at a particular time. So for the next task in our assignment, I will pass to my next group member, which is Sukri. Thank you.
Assalamualaikum. My name Muhammad Sukri bin Barudin, number matrix AA 211998. I will explain how to get the Boolean expression by using K-map. Firstly, we need to get the next state by refer to the state diagram, and then we need to find the flip-flop for C, for B, and for A. After that, we transfer the output that we get from flip-flop, and then transfer to the K-map by using the sequence. After that, we use K-map to get the Boolean expression. That's all from me.
Okay, for my part is the simulation. Okay, from the K-map we can make the circuit implementation, Okay, from this we use two gate, which is AND gate and OR gate, and the square one is the flip-flop of the circuit. After that, we can make the Tinkercad from the software to find the value of the circuit, and this is our Tinkercad link.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Omar Azhar. My metric number is AA 212300. I will be talking about task B. Task B is about parallel in shift registers using 7476 JK flip-flop simulation using Logisim. My job is to construct a 4-bit parallel in load recirculating shift register circuit as shown in figure 2. Initially clear all the flip-flops, then disable the clear inputs and observe the outputs. Verify my work and results and complete the table below. Okay, in this circuit we are going to use 4 input and 4 JK flip-flop, and there will be 4 LEDs that we are going to use in this circuit that will be recognized as outputs for the circuit. The 4 input is the parallel load. When the inputs are 1, when the inputs A is 1, B 1, C 1 and D is 1 and clear is 1, the output at A will be 0, output at B will be 0, while output at C will be 0 and D will be 0. That is for power up. Next we have clear asynchronous. Line number 2. When clear is 0, input A is 1, input B is 1, input C is 1, input D is 1, clock pulse is 0. The output at LED A will be 0, LED B will be 0, C is 0, D is 0. Next we have parallel load asynchronous. Line number 3. Clear. When clear is 1, input A 1, input B 0, input C 1, input D 1 and clock pulse 0. We have a little bit different results from before. That is, output A will be 0, input B, output B will be 1. That means the LED is turned on, and output C will be 0 and output D will be 0. Next we have the shift right, line 4, 5, 6, 7 and 8. At line 4, when clear is when clear is 1, input A is 1, B is 1, C is 1, D is 1, and we have at clock pulse 1, we have output at A is 0, B is 0, C is 0, C is 1 and D is 0. When shift right is 5, we have clear at 1, input A at 1, B at 1, C at 1, D at 1. Clock pulse we be turned to clock pulse 2. Then we will have output A will be 0, output B 0, output C 0 and output D will be 1. At line 6, when clear is 1, A is 1, B is 1, C is 1, D is 1. Clock pulse 3, the output will be at A will be 1, B will be 0, C will be 0, D will be 0. At line 7, clear is 1, input is 1, input B is 1, input C is 1, input D is 1. Clock pulse 4, the output at A is 0, output at B is 1, output is at C is 0, output at D is 0. And then lastly for shift right, line 8, clear 1, input A will be 1, when input A is 1, input B is 1, input C is 1, input D is 1, and clock pulse at 5. The output will be 0 at A, 0 at B, 1 at C, and 0 at D. Next is clear asynchronous. That means we will turn off the clear and make it as 0 at line 9. When the clear at 0, input at A is 1, B is 1, C is 1, D is 1. The output that we will have is 0, 0, 0, 0. When parallel load asynchronous at line 10, clear 1, A1, B0, C0, D1. The output will be inverted. Then the inputs, A is 0, B is 0, B is 1, C is 1, Z is 0, D is 0. Shift right, there will be 5 lines. There's 11, 12, 13, 14, and 15. At line 11, clear, when clear is 1, A1, B1, C1, D1. Clock pulse will be turned on to the next clock pulse, that is 6. Output at A will be 0, B it will be 0, C will be 1, D will be 1. At line 12, clear is 1, A is input A is 1, B is 1, C is 1, D is 1. At clock pulse 7, we will have the same two input, that will be output will be 1, that is input A and D will be 1, and the left is will be 0, like output B and C. At line 13, when clear is 1, input A is 1, B, C, and D also 1. The clock pulse will be turned on the next clock pulse, that is 8. Only A and B will be only A and B output will be 1 only, and C output and D output will be 0. At line 14, clear 1, A input A1, B1, C1, and D1. Clock pulse 9, output A will be 0, B will be 1, C will be 1, D will be 0. And lastly, line 15, clear 1, input 1s, B1, C1, D1. At clock pulse 10, output will be 0 at A, 0 at B, 1 at C, and 1 at D. That's all from me.
Berikut merupakan simulasi yang telah kami jalankan untuk mendapatkan output yang sama seperti dalam, untuk mendapatkan output berdasarkan input yang telah diberikan. Terima kasih.